glad to have you guys join us, all of you folks join us in our webinar today, where we're going to talk about encapsulator agent capabilities to help mitigate hazards in the petrochemical industry. We're very pleased to have y'all. Good morning, good afternoon, good evening, depending on where you're at. My name is Ken Stroud. I'm an encapsulator technology specialist for hazard control technologies, and my area that I service is what I call the best part of the SEC in the United States, and that is Louisiana, Mississippi, Alabama, and Georgia. I have a background that is both in the fire industry and in the oil and gas industry and safety. I have spent over 40 years now in the fire service, all in a volunteer system, and I made my living for many years now in the up to a few years ago in the oil and gas industry as a safety specialist, where I worked in the Gulf of Mexico, primarily on production facilities, some of which had drilling operations going on at the same time as the production, some of which didn't. And I spent some amount of time strictly in the drilling side, doing offshore drilling in deep water, and also spent some time on land in the Western United States in the drilling and well development and workover business. So I've had spent quite a bit of time in the petrochemical industry, and have felt the hazards, personally, that we experience in this industry, and the need to be able to mitigate those hazards effectively and efficiently. So if we're ready, Hernan, to start the show.
We are ready. We can move.
All right.
forward.
So here at Hazard Control Technologies, our goal is to encapsulate the world. We want to do that with a eco-friendly, innovative technology. I can't get this slide to be still, but the encapsulator technology is eco-friendly, it's non-hazardous, it's non-toxic, and it's a game changer in the fire service. And the benefits that it can offer to the fire service, it can also offer to industrial clients, and particularly in the petrochemical industry. It is a tremendous fire suppression product. It's very good at vapor control and liquid hazard control, spill control. It does a fantastic job of helping us mitigate spills. It's very good at tank degassing and tank cleaning for confined space work in a vessel that's contaminated with hazardous materials such as hydrocarbons. So in the industry, these are some of the things we never want to see. Lately, over the last several months, there's been quite a few of these events around the world that have been catastrophic. The one that sticks out mostly in my mind was the tremendously catastrophic event that occurred in Cuba just a couple of months ago, where quite a few of the Cuban firefighters perished in that emergency. What are some of the challenges that these types of emergencies present to us in the petrochemical industry? Well, water supply is one. Traditional means of mitigating these types of hazards and emergencies require a tremendous amount of water, tremendous amount of firefighting agents that we use to suppress these situations. The environmental and health issues associated with mitigating these hazards, these catastrophic events, are also very significant. The traditional methods of mitigating these events have, we now know, created quite serious environmental issues and health issues for firefighters and fire brigades. So there are many hazards in the petrochemical industry, and encapsulator agent, L500 encapsulator agent, offers one solution to many of those hazards. And we're going to talk more about that as we go through the presentation and learn how this one agent can provide many benefits to us. What are the objectives of our presentation today? We want to understand the difference between encapsulator agents and traditional mitigation products that we've used in the past, particularly foam, which has its place in the fire suppression and mitigation business, but encapsulator agents are going to offer us a wider range of benefits and a more effective and efficient way of mitigating these hazards. So we're going to explain the characteristics of encapsulator agents and how to apply them, the most beneficial application techniques for these products. We're going to identify different types of hazards and emergencies where these encapsulator agents can help us a lot. So in the petrochemical industry, in the world I've been in, the petrochemical world, we talk a lot about the upstream, the midstream, and the downstream parts of this business. Oil rigs being in the upstream business face a lot of hazards, flammable vapors and liquids, toxic gases in some areas where H2S can be a very significant problem. Acids that can be used in working over wells to improve their performance, and of course confined space cleaning operations to clean out vessels during routine maintenance and repairs that need to be made to some of the vessels on these platforms. Refineries have some of the same hazards that they have to deal with, the vapors and liquids, toxic gases and byproducts of cleaning processes. Confined space operations, of course, are also very significant for refining operations. Pipelines, of course, some of the same hazards and some of the same issues that we have to deal with dealing with these hazards. So then we move on and we get farther downstream and we start transporting the products of the oil and gas industry to the consumers. And we have trucks going down the road carrying thousands of gallons of flammable liquids that have the vapor issues with them too. But now we introduce mixed fuels because now most of our fuel products that we use on the roads now contain ethanol or some amount of alcohol type solution in those fuels. So now we have a fuel that requires a special type of foam if we're going to use foam to mitigate those hazards. Roadside collisions, of course, are routine and regular, unfortunately, on our highways, and our fire departments have to deal with these on a regular basis. And then these tanks need to be cleaned out periodically too. And so that presents hazards for the workers that are cleaning out these spaces. Then we get down to the gasoline stations, the petrol stations, where our customers are ultimately purchasing these products for end use. Flammable vapors and liquids again present themselves. Mixed fuels again presents themselves. Fuel spills. Fire departments routinely respond to petrol stations, gas stations, fueling stations to deal with fuel spills that occur on those locations. And then, of course, something that's been ongoing for years now in the U.S. and I know in other parts of the world as well are underground storage tanks that have become problems due to their leaking hydrocarbon fuels into the environment. So let's talk about encapsulator agents. What is an encapsulator agent? So an encapsulator agent is a water additive whose basic building block is a spherical micelle. Unlike foam, whose basic building block is a thin wall bubble, encapsulator agents work on a molecular level using encapsulator agent molecules that form spherical micelles when introduced into water. These spherical micelles are capable of encapsulating carbon molecules, hydrocarbon molecules, polar and nonpolar, liquid and vapors, and many other chemicals, lots of chemicals that, we learn more about every day. There's literally tens of thousands of chemicals in the world. And we found many of those that these molecules will encapsulate and render them non-hazardous. So this is how encapsulator agents separate fuel from oxygen on a chemical molecular level. We're going to watch a little video that's going to illustrate
Encapsulator Technology,
how these encapsulator agent molecules
fire
respond
and hazard
when they're added to
mitigation.
water. So the basic building block
First,
is illustrated here. This is a spherical micelle. This spherical micelle forms when the encapsulator agent is added to water, and it forms because the tails of these molecules do not want to touch the water. They're very opposed to any contact with the water droplet itself. And the heads, the white heads that you see in this illustration, are very receptive to contact with water and will attach to the water droplets and will not let go of those water droplets. So in order for the tails to stay away from the water droplets, they'll tuck themselves inward. Here's your head of the molecule, your polar head that's attracted to the water droplet itself and forms a very tight bond to the water droplet. Here's your tail. that does not like the water and will do anything it can to stay away from the water. So when this product is educted, pre-mixed in a tank, run through a proportioning system of most, what happened to my video? There we go. Run through it, most any kind of proportioning system, the tails of these molecules will move away from the water droplet and form these spherical micelles so that they don't have to touch the water. The heads are perfectly happy in contact with the water. Now, when this solution now exits a nozzle and enters the air, the molecules of F500 that are near the surface of the water droplet no longer have to tuck their tails in order to avoid touching the water droplet. So they relax and they let their tails flip out. And so here we have a water droplet that is completely coated with L500 encapsulator agent molecules. And those molecules have relaxed and let those tails stick out. Now, those tails are highly attracted to many chemicals, particularly carbon and hydrocarbon molecules. And so if they come in contact with carbon and hydrocarbon molecules, they will attach to those molecules just like the heads attach to the water droplet. The inside of the water droplet, there are millions of those spherical micelles that are not close enough to the surface to relax and let their tail stick out. And those spherical micelles are just waiting for an opportunity to do more work for us. One thing that they are very, very good at that we'll see as we move along is absorbing thermal energy. All right, now we want the next slide. There we go. So NFPA 18A is an NFPA standard that's been around for quite some time, but it was completely rewritten and it was reintroduced in January of this year, January of 2022. One of the sections in 18A is section 7.7. We refer to this as the spherical micelle stability test. This test is used, it is a procedure to test an encapsulator agent to determine if that encapsulator agent is capable of forming stable spherical micelles that remain stable in the presence of high heat over a long period of time. What firefighters like to call this is a fuel neutralization test, but literally the purpose of this test is to see that the encapsulator agent can form the stable spherical micelles. And when they do this, and when they work like the video we just watched shows us, then they will do their job at encapsulating the carbon and hydrocarbon hazards that we are faced with. So encapsulation, how does this work? Encapsulator agents drastically reduce the potential for reignition because they surround the fuel molecules, and those tails attach to those carbon and hydrocarbon fuel molecules and separate them from oxygen on a molecular level, and they stay there for a long period of time until eventually this product will eventually biodegrade and it will not stay in the environment for a long period of time. But it stays there long enough that the fuel never will become combustible or flammable again. This provides us with very long-term and stable burn back resistance. Rapid heat reduction. This to me is the magic of the product. It's still, after all these years, it's hard to believe how fast we can absorb thermal energy from an ideal H atmosphere, but we do it. We do this by forming a thermal circuit with these spherical micelles and with these water droplets that are coated with the L500 encapsulator agent. So the water droplets are completely coated on their surface with these molecules, and this protects the surface of the water droplet from evaporation. So normally a plain water droplet, in order to remove thermal energy from an ideal H atmosphere, the process is through evaporation. And as the water droplet travels through the extremely high temperature environment, the surface of the water droplet, and actually a very small percentage of the water droplet, converts to steam, and the conversion to steam absorbs thermal energy. The remainder of the water droplet falls to the floor, which is the coolest place in the room, I say. Excuse me. And this stops the water droplet from removing thermal energy and helping us mitigate this high temperature environment. But when we add the encapsulator agent to the water droplet, it coats the surface of the water droplet, protects it from evaporation, and the heads of the molecules quickly transfer thermal energy to those waiting spherical micelles that are on the inside of the water droplet. Those millions of spherical micelles that are hanging out on the inside of that water droplet absorb this thermal energy, we like to say, like a Ferrari, and then they slowly dissipate that thermal energy into the rest of the water droplet. So what this does is this allows our water droplet, rather than essentially in a two-dimensional way via evaporation to absorb thermal energy, we're now absorbing thermal energy into the inner part of the water droplet and doing it on a three-dimensional basis. This gives us many orders of magnitude better efficiency at absorbing thermal energy. In fact, in the process of absorbing that thermal energy in our firefighting demonstrations and in real world examples, we find that we're unable to produce steam. Free radical interruption, another process another technique that the encapsulator agent uses to help us eliminate suppress the fire, is by interrupting the free radical process. So this free radical process is taking place, just above the fuel. So as the fuel gets hot and reaches its flash point, it begins to off gas. And this off gas is full of these charged particles that we call free radicals. And this is where your vapor phase combustion is taking place. The physical size and mass of these spherical micelles that are created when we add L500EA to the water physically interrupts the movement of these free radicals and stops the process, stops the vapor phase combustion. And during this combustion, the free radicals, the fuel that does not burn, we know it coalesces and forms the smoke and toxic gases above the fire area. And so if we interrupt this free radical process, which is part of our fire tetrahedron, we also interrupt the production of smoke and toxic gases. And so in this way, we can remove that smoke and the toxic gases from that IDLH atmosphere. And again, we're doing this in front of the nozzle. So this is an incredible proactive safety measure, safety benefit. So here's our fire tetrahedron, and we're talking about interrupting various parts of the fire tetrahedron simultaneously. Encapsulator agents are capable of doing this. So if you remove any part of this fire tetrahedron, then the fire goes out, right? So if we remove the oxygen, the fire goes out. We remove the fuel, the fire goes out. We remove the chemical reaction or the heat, and the fire goes out. So we've talked about encapsulating the fuel on a molecular level, separating it from the oxygen, molecule by molecule. And this removes the fuel technically from the combustion process, and it removes the oxygen. So this puts the fire out. We've talked about how we remove heat using a thermal conductive technique by moving thermal conveyance, by moving the thermal energy into the inside or three-dimensionally into the water droplet. So we're removing heat very quickly, so quickly that we don't make steam. We'll create an environment that goes from 1200 degrees to 120 or 30 degrees, literally in a few seconds, 3 to 5 seconds. So we're removing the heat from the combustion process. And when we do that, the fire goes out. And we just talked about the chemical reaction and the free radicals and how the spherical micelles interrupt the chemical reaction. And this also extinguishes the fire. What types of fires can encapsulator agents help us suppress? Well, let's just look at all of them. Class A fires, Class B, 2 and 3-dimensional fires, Class D are burning metal fires. It's very effective at extinguishing these fires without creating explosions. It's very effective at extinguishing lithium-ion battery fires. It's the only product that we know of that right now is proven over a long period of time. We've got 10 to 15 years of very successful third-party, very scientific testing that's been done that proves that we can encapsulate the electrolyte in a lithium-ion battery, and that we can remove the heat from that electrolyte and quickly lower it below its ignition point and extinguish those fires. Okay, speaking of lithium-ion battery hazards, and this is a hazard that's growing, I guess it's multiplying, it seems like, sometimes on a monthly basis. It's been hot in the news lately because of the hurricane that landed in Florida recently, Hurricane Ian. And there's a lot of challenges that the local fire departments have been facing with electric vehicles, and these vehicles igniting after being submerged in water. Sometimes that's salt water. And the fire departments are facing a lot of challenges with trying to mitigate these hazards. Are we still online? I just had a message popped up that said the meeting ended. Are we still going?
I got you, Ken.
You still got me. Okay. I guess that was just a trick message to make me think y'all had had enough. Well, I'm not finished yet. Okay. So these hazards are something that we can mitigate. We've been to several events lately where we've been very successful in extinguishing lithium-ion batteries. I know that during my time in the oil field, we had lots, I can say, of battery-powered energy storage systems that were used to back up our emergency systems, our sensors, and our alarms and things of that nature to keep us safe. And in those cases, I know that there were efforts being made to look at better technology than the lead acid batteries that were being used at the time. And so these are situations where we can use systems to protect those batteries from fires should something inappropriate happen in a fire start in these systems. So NFPA 18A that was released in January of 22, Annex 4.3A, Annex 4.3 expounds on the testing and stuff that's been done with encapsulator agents, the successful testing that has shown its ability to extinguish lithium-ion battery fires. So the product is eco-friendly. Number 4, encapsulator agents are eco-friendly. They're fluorine-free. There's no need to use PFAS chemicals in an encapsulator agent. It works differently from foams, and it doesn't have to form a film like foams do. And so there's no need to have the PFAS chemicals in these products. It's biodegradable, so it does not linger in the environment for long periods of time like the PFAS chemicals do, and it's non-corrosive. So as this crisis comes to a head around the world with the fluorinated compounds, the encapsulator agents, the F500 encapsulator agent offers an eco-friendly solution. So fire suppression, how can encapsulator agents help us with fire suppression? So how do they help? They help with safety, health, and efficiency. Like we've talked about already, the encapsulator agent, when it's mixed with water, it forms these spherical micelles that coat the water droplets and change the thermal energy reduction technique that the water droplets use. The tails that are sticking out when they're exposed to smoke and toxic gases of many different kinds, they encapsulate that smoke, they encapsulate those toxic gases on a molecular level, and they remove those things from the atmosphere literally in front of our nozzle. And so they remove those things before our firefighters or fire brigades are exposed to them. The product is 100% fluorine-free and non-corrosive and biodegradable, like we've already talked about. So now we're reducing the cancer-causing toxins that have been in our traditional firefighting additives that we've used, for the last 50 years or so. So we drastically reduce health risk and improve conditions for firefighters and for trapped civilians. So I'll tell, when I'm doing a firefighter training scenario with fire departments, we talk about the two things that are killing our firefighters and killing our civilians. And those two things, primarily those two things, the ones that are acute at least, are the incredible temperatures and the toxic gases and smoke. And this product does an incredible job of removing both of those or all three of those from the atmosphere. How does it help us be more efficient? We rapidly extinguish fires, and this translates into less time, less exposure, less damage, and less labor for our fire brigades. And any time that we can expose ourselves to those dangerous environments for a shorter period of time, that directly improves our safety and our efficiency. So fire suppression industry benefits then: rapid heat reduction. It's safe to use in combination with other agents. It's safe to use for three-dimensional fires in tanks and distillation columns and valves, and works very efficiently on three-dimensional Class B fires. This is something you can't do with foam because foam won't form a blanket, of course, in a three-dimensional orientation. It can be used to rapidly prevent the spread of fires to nearby structures by providing a thermal barrier between the active fire and the exposures to prevent the radiant heat from igniting those exposures. And it's safe to use in an energized environment. It's been tested by FDNY, as a matter of fact, and Con Edison against 345,000 volts. So this is an older video, or at least the video looks older. This was testing that was done in China on comparing encapsulator agents, or F500 encapsulator agent in particular, against traditional firefighting foams for a flammable liquid storage tank scenario. And what I want to do is I want to slide through this and speed it up a little bit, because and we'll stop at the points that are most significant for what we want to see here. In the first scenario, they're going to use the F500 to extinguish this fire. So it's a large tank fire. It's a large size tank. It contains approximately 574 gallons of diesel fuel. They're going to use a 3% solution of water and L500 encapsulator agent, and they're going to use one monitor that discharges 570 gallons per minute for a flow rate. And the video equipment's not as impressive as the firefighting equipment, but bear with us here because the facts are the facts. So here we go with the L500 encapsulator agent with the single
tank was 65 feet high,
nozzle at
with
500-something gallons per minute.
Of
you notice they're raining this
the
fog
diesel
down on
fuel
top
was 3
of this
feet
fire,
4 inches
and
deep,
it's going to
totaling
begin
about
to
574
interrupt
gallons.
the free radical
Pre-burn
process
was
in the vapor
15
phase.
minutes.
It's going to start removing the smoke from the
The
environment.
monitor
And
flow
as it
rate
removes
was
the heat and falls down
570
onto the
gallons
fire,
per minute,
it's
and
going
both the
to
F500
reduce
EA
the fuel
and
below
the
its target
AFFF
ignition
were
point
proportioned at
and
3%.
extinguish the fire. And it does so very efficiently.
Extinguished the fire in 58 seconds with one monitor.
This diesel fuel
About
fire
552 gallons of
please
solution
shut
was
down
used,
the
with
sound.
about 16.5
down
gallons
the
of
sound. Let's see
F500
here.
EA.
How's that?
Thank you.
Okay. So we used in this demonstration, it took 58 seconds to extinguish this diesel fuel fire. And I can't get the little thing to let me drag across here very well. There we go. They used a total of 552 gallons of solution, which turns out to be very similar to the volume of fuel that they were trying to extinguish. And they only used 16.5 gallons of L500 encapsulator agent to mitigate this fire. So now we're going to attack the same kind of fire, 574 gallons of diesel. We're going to use a 3% solution of what we've used in the past, the AFFF foam. In this case, they're going to use two monitors with a total flow rate of 1,140 gallons per minute. And so now, like foam does, we're trying to create a foam blanket across this fuel so that we can smother the fire out. We can physically remove the fuel from the oxygen by laying a blanket of bubbles across that fuel. You notice there's actually more than two lines being used, because there's hand lines down here coming from the ground that they're using to cool the sides of this vessel so that they can lower the temperature of the vessel itself so that it doesn't try to reignite the fuel. Now, the L500 encapsulator agent provides that benefit for you while you're extinguishing the fire by doing an incredible job of removing thermal energy from both the fuel and the infrastructure around the fuel. So 1,140 gallons per minute of AFFF. And in 7 minutes and 35 seconds, they called extinguishment. They used 8,655 gallons of solution and 260 gallons of AFFF concentrate to extinguish it using foam. So in summary, the L500 extinguished the fire in 58 seconds versus 7 minutes and 35 seconds. They used 16.5 gallons of the L500 concentrate versus 260 gallons of AFFF foam, and they used a total amount of solution of 535 gallons versus 8,395 gallons. So the encapsulator agent, the F500 encapsulator agent, is far more efficient at extinguishing this fire and preventing reignition of this fire.
Technology.
Okay, I hope the sound will work on this one because the sound is wonderful.
Hazard Control Technologies presents F500 Encapsulator Technology. Industrial
I can barely
fires.
hear it. Can y'all hear that?
They're one of the most dangerous aspects of any industry's production. One spark can cripple operations and cost lives. But now, even the biggest fire disasters can be prevented, controlled, and contained. It's possible, thanks to Hazard Control Technologies, Inc., a breakthrough combination industrial vapor encapsulation, explosion prevention, and 3D Class B
Okay,
fire suppression system is now available.
That's one of those scenarios, of course, that in an offshore environment where your choices are extinguish the fire or go over the handrail, get in the lifeboats. That's a very scary scenario when you're on a production platform in the ocean and you realize you're working on a bomb. And if you get a valve, you get a blowout somewhere with a gas leak, and that gas leak can change your day and ruin your life. And these create very catastrophic situations in the oil and gas industry. And what we're seeing here is we're seeing a very fine mist of 3% L500 solution being discharged onto a leaking valve that's discharging both liquid and vapors. And you see very rapid extinguishment of that fire. This is something you just literally cannot do with foam. You cannot do this, to my knowledge, with any other extinguishing agent, not at this kind of rate and not this permanently.
Fire suppression system is now available. By combining HCT's F500 encapsulator agent, flammable liquid vapor encapsulation, and three-dimensional Class B fire suppression capabilities, with our Veep rotating nozzles, a containment system was designed to control and contain explosive vapors, liquid, and gas fuel fires.
We cannot listen to you.
Systems are available to cover areas both small and large, from pump transfer stations to...
Okay, so as I was saying here, and the video just took off without me. So this is a situation where we're illustrating, we have a vapor leak or a flammable liquid leak, and the sensors detect that leak, and these nozzles can discharge before the fire ever ignites, and they can prevent the fire from ever occurring by encapsulating both any liquid and vapor, flammable liquids or vapors that come out of these failed valves or flow devices. And of course, this is far, far better than letting the fire occur to begin with. In this scenario, we're looking at flammable vapors, like propane, for example. Here we have more flammable vapors in liquid, and here's the discharge of the vapor producing nozzles, the very fine particles of droplets encapsulated with the F500, and the very rapid extinguishment of this fire.
With F500 EA Veep system. Contact Hazard Control Technologies. We can discuss how we can put this engineered advantage to work for you. Protect your personnel, protect your assets.
Okay, vapor and spill control. Well, we just saw a lot of vapor and spill control, especially when it comes to preventing fires. But let's look at this a little more. So vapor and spill control. This is again, what kind of how can these encapsulator agents help us mitigate spills? Safety, the safety benefits, we provide neutralization of that fuel. That test, that NFPA 18A 7.7 spherical micelle stability test, does show us that we encapsulate hydrocarbon fuels on a molecular level, and we render those fuels non-flammable and non-combustible. This is a process that renders that fuel non-hazardous on a permanent basis, unlike a foam blanket, which is temporary and then has to be maintained. Economy, it helps us with the economy of mitigating these incidents because it is quick. It provides very little runoff, which reduces the environmental impact of mitigating these incidents. And it dramatically then reduces the cleanup cost compared to foam. And the foam then again, like I said, has to be reapplied. And so it produces an even larger cleanup issue. So efficiency. So compared to other agents, the encapsulator agents require very little agent, water, time, and labor. So the benefits, of course, so one of the benefits is that encapsulator agents can be mixed with salt water or fresh water for spill control on petrochemicals. In most areas, the local regulations will allow you to simply leave these products in place once they've been encapsulated and allow nature to take care of them. In some jurisdictions, this won't be the case. And in many jurisdictions, this is the case. And we find that in those jurisdictions where it's not, it's simply a matter of education where we can cross that bridge with those guys. So encapsulator agents alter the properties of the fuel and prevent reignition. So they remove the flammable or combustible hazard from these spills. So this is going to be a video that's going to show us that process of mitigating a fuel spill. So we have a fuel spill on the pavement here, and our firefighter is going to come in with a 3% solution of L500 encapsulator agent and render part of that fuel spill non-flammable. And now we're going to ignite the other side of that fuel, and you see, of course, that the fire is not propagating into the treated part of that fuel because that fuel has been rendered non-flammable. Now the firefighter is going to come back and very quickly, he's going to extinguish the burning portion of that fuel in about 2 seconds. Now, unlike a foam blanket, that if you disturb that, the foam blanket would not lower that fuel below its auto ignition temperature. And if you disturb that foam blanket, you can reignite that fuel because it's already hot enough to burn. In this case, the fuel is encapsulated on a molecular basis. And you see, even when the firefighter disturbs the encapsulated fuel, it does not change its characteristic. It does not make it flammable again. So the fuel does not reignite. Tank cleaning and degassing. This is a big deal for us in the petrochemical industry. We expend a tremendous amount of time cleaning out vessels and making those vessels safe so that we can enter them and perform those cleaning operations. How do encapsulator agents help us with tank cleaning and degassing? Encapsulator agents assist with rendering the products that are in those vessels, the sludge, the flammable vapors, the flammable liquids, rendering those products non-flammable, non-combustible, removing those vapors from the atmosphere by encapsulating them and rendering that atmosphere non-flammable and non-hazardous. So, and it's very efficient, it's very effective. Traditional means of safing out these vessels is very time-consuming and not as environmentally friendly as using the encapsulator agents. So the benefits, of course, we enhance safety for the workers, we enhance safety for the facility, and we substantially reduce our overall cost for cleaning out these vessels. One way we do that is we reduce downtime by 60% or more. Using the encapsulator agents to remove the flammable vapors and encapsulate the flammable liquids is far faster than purging those vessels with inert gases and ventilating those vessels until you can remove certain volumes of air from those vessels until we reach a point where we consider them safe to enter. So we dramatically cut our cleaning cost. We minimize our environmental impact. And in the event where we have H2S in these vessels, we can encapsulate those H2S vapors and render them non-hazardous and non-explosive also. So here's an example of a tank at a facility that needed to be cleaned out in Trinidad. So this was a diesel fuel container that contained it would hold about 60,000 gallons of fuel. And this fuel became contaminated with a fungus that we call the diesel bug. And so therefore it needed to be cleaned out. So in order to clean this out, the contractor, of course, mobilized on site and started working on making this a safe operation, right? So they needed to remove the residual contaminated fuel, and this fuel was transferred to RTW for removal. I'm not actually sure who RTW is. Okay, so we started the company started the cleaning process and used an encapsulator agent, used F500 encapsulator agent on the above ground storage tank internals. So now the encapsulated flammable liquids and vapors were rendered non-hazardous, and the fuel was able to be removed. The vapors, of course, were removed, and this was done in 1 hour. They went back in with a hydrojetting equipment and cleaned the material out of the tank to make it ready for reuse. And here's pictures that illustrate some of the material that was removed. So like in this photo here, you see some of the sludge and scale that was removed from inside of that vessel. And here you see the vessel in the bottom right in the photo after the cleaning took place. And you see that the product did a very good job of removing residual from that vessel and getting it ready to put back in service. So cost comparison. There's a cost comparison from Brazil that comes to us for tank degassing. So here's a situation where we're taking a 14.5 meter high, 9 meter diameter, 1 million liter vessel, and we want to safe that vessel out. Traditional methods would have us purge that vessel of flammable vapors using nitrogen, which of course is inert. And this is a 12-hour downtime operation where we're treating the vessel for 6 hours and then we ventilate it for 6 more hours after that. So the nitrogen is injected for about 6 hours and combustible vapors are simply ignited and torched and burned off. Of course, this is somewhat of an environmental impact, but it's the way that this is often done. And then a door is opened at the base of the tank where LELs are checked. If the LELs are found to be good, then the process can continue. If the LELs have not gotten down to a safe level yet, then nitrogen will be reapplied for 2 more hours. The tank is then left open to ventilate naturally for 2 hours, and then it's ventilated manually for another 6 hours. So this is a very time-consuming process where we remove air volumes from this tank until we reach a point where it's safe to enter and do the cleaning or repairs or whatever needs to be done on the inside of these vessels. Now, when we used F500 encapsulator agent to safe out these vessels, of course, the same vessel, same size vessel, we used 60 liters of F500 EA using a 3% solution. The downtime now went to 20 minutes. It took 20 minutes to treat the atmosphere, to remove the flammable vapors, and to render non-flammable or non-combustible the liquid residue that was inside the tank. And once the vapors are rendered non-flammable and the liquid has been encapsulated and rendered non-flammable, non-combustible, there's no need for ventilation time. So during this degassing process, one of the lateral doors at the bottom of the tank was opened. The 3% solution of encapsulator agent and water was sprayed for 20 minutes in a fog pattern using a 30 to 60 degree fog pattern. And so this exposes those coated water droplets in the atmosphere to the hydrocarbon vapor molecules and allows those hydrocarbon loving tails that are on the outer surface of the water droplet to grab onto the vapor molecules themselves and encapsulate them and remove them from the atmosphere. And so using a fog pattern and using lots of small droplets increases the efficiency of that process. So the LEL is measured at both the open door and in the container pool. And when the LEL is verified to be 0, then the tank has been degassed. There's no need to ventilate the tank. All the flammable gases and the residual liquid have been encapsulated and rendered non-hazardous. So then the encapsulated liquids that are at the bottom of the tank can be removed and the cleaning can continue. So how does this help? us in the petrochemical industry. It decreases labor cost, as you can see, very significantly. It decreases time. It minimizes injuries or exposure to injuries, and minimizes the effort that the employees that are doing the work are having to exert, sometimes in inhospitable environmental conditions, and increases safety in many ways. It minimizes the downtime of the tank and gets it back in service much quicker, and minimizes the owner of that tank's wait time, and it decreases the environmental impact by encapsulating these fuels and vapors and rendering them non-hazardous. So equipment and engineered systems. Let's look at what Encapsulator Agent can do on another level. So it's not only good when you discharge it out of a nozzle for manual firefighting techniques, it also is very effective when it's incorporated into engineering fire suppression equipment. Let's have a look at that. So some of the portable equipment that Hazard Control Technologies offers, of course, we offer the traditional 2.5 gallon water can, we call it, or water fire extinguisher, and TKO nozzles. This is a nozzle that we have that has a built-in ejector in the nozzle itself, and holds 2 liters of concentrate literally right there under the nozzle. This is a very effective firefighting tool. We have piercing rods that are very popular in the coal industry, for example, to reach deep-seated fires. And these piercing rods are like fire department piercing rods on steroids. These are very heavy-duty piercing rods that can be used to pierce very deeply into deep-seated fires. We have mobile equipment. Like in the picture here, we're showing 2 of our QAMUs, or quick attack mobile units. These are water cans or water fire extinguishers on steroids. These are very large, pre-pressurized and pre-mixed 3% solutions, water-based fire extinguishers. We have portable carts that are not illustrated. These are carts that work much more like the TKO nozzle in that you connect a water supply to these carts, and they can contain either 100 or 150 liters of concentrate and can go on for long periods of time, providing anywhere from a quarter or half up to 3% solution for firefighting. We also offer mobile response trailers or skid units that can be very large in size and provide very long-term firefighting capability. So now let's look at another piece of equipment. This is a piece of equipment that is designed to work with F500, and it provides us with a means to incorporate the Encapsulator Agent technology directly into your sprinkler systems or your deluge systems. So the Diamond Doser is a water-driven proportioner. It's very innovative. It's very reliable. It's very easy to use. It's easy to install. It's easy to take care of. So it's a very user-friendly piece of equipment and a very accurate way to proportion Encapsulator Agent into your water flow for your engineered system. It is water driven, so it doesn't require any external power source. As you can see in the illustration here, this Diamond Doser is connected inline in your water flow. And so when your water flow initiates, it starts active. The water flow itself moves the piston pump. The concentrate is provided by a large capacity, however large it needs to be, gravity-fed atmospheric storage tank that injects the Encapsulator Agent downstream of that water-driven proportioner into your water flow. So now when your deluge system or your sprinkler system activates, you automatically get whatever percentage of encapsulator solution that we determine is best for your particular hazards. So the solution flow capability has a very wide range. There's no waste of concentrate. Like I said, there's no external power source required. The flow of the water through your system is what powers the water-driven proportioner, and the maintenance is minimal. It's easy to take care of. The expense is a very economical piece of equipment to install into an existing or into a new system. And the encapsulator agents, of course, are multi-purpose and work on all different types of fire classes very efficiently, including the lithium-ion batteries. So here's a little cartoon that illustrates the water-driven Forstner and what it looks like and how it works. And I'm going to turn the volume down here as well. So as you see, here's your water-driven pump. And it is connected to a concentrate pump. So as the water flows through the water-driven pump, it turns the concentrate metering pump, which picks up the concentrate from an atmospheric gravity-fed tank. And this system is just built right into your existing water flow. The faster the water flows, the faster the pump works. And each different size of diamond doser has a very wide range of flow capabilities. And so in this case, you're just discharging water, but as the system activates, and in most cases, this would be already open, but in some cases it can be manually opened. And so now your concentrate gets picked up by your pump, and it gets pumped into the downstream side of your flow, downstream of your water-driven pump, and discharges out through your monitors or out through your sprinkler heads. It's very easy to maintain this piece of equipment. Should you have a discharge, there's a bypass system on it where you can shut off the flow of concentrate. You can flush it with fresh water. Although the encapsulator agent is very user-friendly to the equipment, it won't clog up stuff like foam wheel, and it's non-corrosive. It's certainly good practice to go ahead and flush it with fresh water. So some more services that Hazard Control Technologies can provide to the petrochemical industry is consulting and training services. So we can help you with a hazard analysis. We can look at your various fire and spill and hazmat hazards, and we can help you determine if encapsulator agent would be a good product for you to use to mitigate those hazards. We can look at your fire protection and your fire exposures and help you do assessments and determine how encapsulator agent might fit into that piece of your protection puzzle. And we can help your fire response teams and your fire brigades by providing planning for those groups to help you know the best ways to use encapsulator agent and get the most benefit out of it. So we can actually take that a step further and actually provide training. So we can provide training to your fire brigades and fire protection teams for encapsulator agent application and help them understand the most efficient ways to use the product and get the most benefit out of it. We can look at your special hazards, such as your battery energy storage systems, and we can help provide training on how to handle those types of emergencies should you have them. And of course, provide training for your emergency response teams in general. So that is the end of our presentation. And here's where we open the question and answer period. Should we have anybody that has any questions or is looking for more answers? If you have any observations or ideas that you'd like to share during our webinar, we'd welcome those. Everybody for joining us. We appreciate your participation. We enjoy sharing these capabilities with the brotherhood, so to speak, and we enjoy sharing these capabilities with industrial partners as well. We appreciate y'all joining us, appreciate your questions. And if you have any more questions that you think of at a later time, then reach out to us and we'll be glad to help you.